Now the line, it should go through the starting point and ending point. Now let me see what is the starting point and what is the ending point. Assume that this is the starting point. And this is the ending point. If you have given the starting point and ending point, you should be able to draw a line. That is the way you draw the lines in draw lines on the computer applications. Corel Draw, Photoshop, even this particular line, I have to take from starting point to ending point. Now this is going through the starting point and ending point. So the line equation also there. Line equation y equal mx plus c. What is this y equal mx plus c? If this is on a, sorry, this type of Cartesian plane, this this is y-axis, this is x-axis. Sorry, this is x-axis, this is y-axis. Sorry, let me have a piece of water before continue. Now we have the starting point and ending point. So in this type of equation, what we can see is that if you have given some kind of x value, suppose here we have x here, and at the same time you have y somewhere here. Y here. Now this is what we take as x comma y location. When we substitute, now let me change this values y m x plus c. Right. So here this y, when we substitute y value x value with this x value, and this gradient is there, then you are getting the y value here. Therefore, if this line equation is y equal mx plus c, we know what is c and m. Then when you substitute the x coordinate, you can get the y coordinate. That is the only help you can get from this type of equation. We have discussed last time to draw a line, the fundamental requirement is starting point and ending point. Now, what is this M? M is the gradient. We call that one as gradient or slope. Right? Gradient or slope. The slope is given by normally denoted by some kind of a location. We can draw the slope. We can take 2 points like this, and we can take the difference here, the height in between these 2 points, and the width in between these 2 points. When you take the height divided by width, that is what we take as slope. Now here this one can be taken as dy, and this one can be taken as dx, the width. The smaller difference in between 2 points, the 2 points are here. 2 points on the line. Then that we take as a slope of that particular segment. This dy is the smaller height. This dx is the smaller width. Now, what is this dy and dx having relation to these 2 points? Suppose these 2 points are x1 or x2, comma y2. Suppose this is x2, comma y2. The next one I am taking x1 and y1. This is x1 and y1. Therefore, we can write that any 2 points within that line, and there are x difference and y difference. When we divide the x differences by y differences, by x differences, then we are getting the slope. That is what we call as slope. Right? Remember these parameters. Now, therefore, we can write dy equal y2 minus y1, and dx equal x2 minus x1. Right? I think it's clear, right? Understood or not? Hello? Is that clear? Right. Now we know what is the 2 differences, and that is the slope. Now we can write m equals, that's the slope, equals dy divided by dx. That small difference in x direction, y direction divided by x direction. That is the slope. Now, in other words, when we take this particular equation, suppose that one point to the other point, you can get the difference. Now, suppose this x1 and y1 and x2, y2, both are on the line. Both these points are on the line. Now, assume you have to understand this one is here. This point. This point is a separate point, right? This one is a separate point. Now, when we consider about the equation y1 equal mx1 plus c. And also you can write y2 equal mx2 plus c. It satisfies both these two equations because those 2 points are on the line. Right? Now, this is normal in mathematical manner. This is the mathematical representation. We know that in a line which is represented on a computer screen, a line represented on a computer screen will be drawn on pixel plane. Those are drawn on pixel plane, not anywhere else. Right? The lines are drawn on the pixel plane. The pixels are separate from one to another. Now here, when we are drawing a line on the computer screen, we have to identify what are the pixels on the line, what are the pixels to be drawn as a line pixels. Right? What are the pixels to be drawn as line pixels? Right? So that is one of the things we have to keep on our memory. Because our plane is not like, fractional values. It's not available with fractional values, and we are going to draw the things on pixel by pixel locations. We are going to draw things on pixel by pixel locations. What we can do here is, we definitely know when we were asked, now these are the properties of any line, right? These are the properties of any line. These are the general properties of any line, given line. Now, when we want to draw a line on a computer screen, normally we have to give what is the starting point, what is the ending point. Then the rest of the points in between, you have to find. That is the task to be done in the computer. Computer එක line එකක් අඳින්නේ කියලා කිව්ව දුන්නට පස්සේ line එක අපි computer එකට දෙන්නේ starting point එක ending point එක. Computer එක එතකොට process එක අඳින්න ඕනේ graphic application, but graphic application has to draw other rest of the points. Then what that application has to do? That application has to calculate what are the other points in between. Points දෙක අතර තියෙන අනිත් pixels ටික මොනවද කියලා හඳුනා ගන්න. Therefore, to identify those points, to draw a perfect line, we have to do here. To do that, there should be a program. To calculate what are the points in between, we have to do the calculation. That calculation is to be done through a program. That is what we call as an algorithm, a methodology to calculate those in-between points. Right? Is that clear and understood? Yes or no? Yes or no? Hello? Is that clear? Huh?
Yes, sir.
Okay. Now, let's see how are we going to do that and derive an algorithm to calculate these points. Assume that you have already given 2 points. I'll go to the next section now. You were given 2 points. 2 points are given. I'm giving those 2 points as x1, y1, and here I have another point, x2, y2. In between these 2 points, I have to draw the line. Right? In between these 2 points, I have to draw the line. Right? Right? So, in between, we have to find what are the pixels available. What are the pixels available? We have to find it. Now, one thing we can definitely calculate, that is their slope can be calculated. Slope, comma m equal, we know that dy is y2 minus y1 divided by x2 minus x1. Starting point and ending point, and there are differences taken in that. So the m is there. And next thing what we can write is that y equal mx plus c type of equation can be applied to this particular line. Therefore, what we can write is that we definitely know x1 comma y1 is on the line. Now, if you want to take it down, you can take it down. What I am doing here is actually I am describing how I am doing the first algorithm. My derivation here going to derive with the derivation of digital differential algorithm. Differential analyze algorithm, sorry. Analyze algorithm. Digital differential analyze algorithm. That is my target. Okay. Therefore, remember this x1, y1 is on the line. Therefore, this x1, y1 should satisfy this particular equation. Therefore, I will write y1 equal mx1 plus c. y1 equal mx1 plus c. Right? Now, I know that x2, y2 also on this line. I can apply the x2, y2 also. But that is not my target. My target is to go to find the locations or the pixels which are in between these two lines. Right? For example, here, now I am drawing the mesh. Pixel plane. I am drawing the pixel plane now. Understand this one very carefully, then you can understand the other things very easily. earlier the approximation and all these things were discussed to discuss these important factors. Suppose these are pixels. Now what I know is that this one here, this particular pixel is drawn. That means we have to mark this one. I think the color should be black. Okay. And here we have the endpoint. Now in between, what are the points? Now we have to mark them, right? When we are marking it, we know that this one is already done. Y1 equal mx1 plus c. Now, when we are drawing line, definitely we know that we have to draw the line this way or whatever the next position. Therefore, we have to understand now x1 is there. What is the next pixel point we have to identify? That can be x1 as it is and here, or x1 this way and x1 this way. Go. So y1 is here. Now let's see the situation, the real situation. This direction we have x1 and then x1 plus 1. The next position is x1 plus 1. Right? Now, next box is x1 plus 1. Here also the same. This is y1, but here it is y1 plus 1. This particular location. Now, what we can decide is we have to go from here to here now. So we have to decide how are we going that. The only thing is we have to know is that this is going this direction, therefore we can increment on next direction. When we increase on next direction, what is going to happen? That we can check. By increment on x direction, x coordinates goes from x1 to x1 plus 1. අපි x direction එකට එක pixel එකකින් වැඩි වෙනවා final. That is this line. Now we have to identify which point to be drawn. This one or this one or this one or this one. That we have to identify. Now x will become x1 plus 1. This x will become x1 plus 1. We don't know what is y. Let's write that y, that will be written as y dash, okay. Y dash equal m x1 plus 1 plus c. M x1 plus 1 plus c. Because if that line, that point is on the line, that point should satisfy the line equation. A point එකත් දැන් අපි හඳුනා ගන්න point එකේ අනිවාර්යෙන් දන්නවා මේ පැත්තට x ධන 1 ඒ කියන්නේ ඊළඟ පොයින්ට් එකට යන්නම ඕන මේ හරිය මොකක් හරි ඩොට් එකක් වැටෙන්න ඕනනේ මේ හරිය මොකක් හරි ඩොට් එකක් වැටෙන්න ඕනේ එතකොට ඒ හින්දා තමයි මේ x1 + 1 වලට යන්නේ නමුත් අපි දන්නේ y වල මේකද කියලා අපි දන්නේ now අපි y dash that's why we don't know okay therefore what we are going to do is we have to calculate the next one now I will take this equation as the equation 1 and then I will take this equation as equation 2 this is equation 2 so the equation 1 is here equation 2 is here now let's see the subtraction right let's see the subtraction from one to another from one end to another end we can do the subtraction here mx1 plus m right this can be written as mx1 plus m so we can write y dash equal mx1 plus m we multiply it by m plus c okay that the same the second equation can be expanded like this then we can write 2 minus 1 by subtracting the second equation by first equation we can derive මේ දෙවෙනි equation එකේ පළවෙනි එක අඩු කරාම y dash minus y equal mx1 minus mx1 cancel out you can clearly see that these two will cancel out with each other c to c cancel out what is remaining y dash minus y equal m remains then ultimately we can write y dash okay sorry this is not y1 y dash equal y1 plus m y1 plus m okay now suppose this is the next second point now this is the main thing we have to understand this is the main thing we have to understand when we do 1 pixel incremented on x direction x දිශාවට 1 pixel එකක් පැන්න ගමන් ඒ point එක වෙන්නේ y කණ්ඩායමේ වැඩි වෙන්නේ මේ අනුක්‍රමණය so when we are increasing 1 pixel on x direction the y coordinate will increase by a fraction of slope a fraction of slope will be incremented in the y direction when we increment on x direction 1 pixel we know now the x coordinate we know why we have incremented from the starting point 1 pixel x ඉස්සෙල්ලා තිබුණේ 4 නම් දැන් 5යි. අපි x කන්නාගේ දන්නවා. We know what is x because if it is earlier 3, now it is 4. But we don't know what is the y. Our y will be calculated in this manner. So when we increase 1 pixel, the y direction, how much it will increase? The slope equal to the slope amount it will increase. Now we know that the slope can be fractional value. एक दशम කියන්නේ भाग संख्याවක්. That can be a fractional value. But these pixel locations are integers. पूर्ण संख्या. Nikhil. Right? Therefore, we have to get the y dash by rounding of the value y1 plus m. So always this is the way we have to calculate. When you calculate, okay, suppose we have calculate y1, then the y dash is known. What is the next point? Then for the y dash, you have to, that may be y double dash. Y double dash equal y dash plus m. අපි ඊළඟ එක කැල්කියුලේට් කරාට පස්සේ තමයි ඊළඟ එක කැල්කියුලේට් කරන්නේ. අපි y වගේ සෙල් එකේ y වගේට m එකක් එක්ක අහුවනාම එක පික්සල් එකක් ගියාම ලැබෙන්න ඕන තැන. So ultimately you have to go until the last point x2 y2. Then when your x coordinates equal to the x2, you can stop the algorithm. When you go to the x equal x2, you can stop the algorithm. Until that point, you have to go. And you can check whether that is equal to the y2, the y coordinates of that function. Whether it is equal to the y2. You can check it. Right. So that's how these things are happening. That's how these changes are happening. Therefore, be clear about this. Always the previous calculation, what we have done for the y, is used to calculate the next one. That is how we are going forward. Right? That is how we are going forward. Right. So now what we are going to do is we are going to derive an algorithm for this line drawing, right? We are going to derive an algorithm for the line drawing. For the inputs for this algorithm, the inputs for the algorithm is going to be, now we know how to calculate this m, right? M can be calculated by using the two endpoints can be divided one by the other and you can calculate it. So this is how we are going to do. Let me write the algorithm step by step. Take inputs of two endpoints. Two endpoints. So two endpoints are going to be x1, y1 and x2, y2. right? X1, Y1 and X2, Y2. And then what we have to do is we have to calculate the slope. That is the first step. This is the first step. Then the second step is calculate the slope. Right? Slope M equal this one. Third step. Third step. After calculating the slope, we have to plot the first point. Plot X1, Y. Right? Then, after plotting that one, the fourth step is a repeat, iteration. Repeat what? That repetitions have to be done. Increment alone X direction by 1 pixel, not needed pixel. Calculate Y by using Y equal K. By using Y dash equal, Y dash is the next question. Now here we have to write X dash equal X1 plus 1. Oh, X plus 1. Current X position plus 1. Current X position plus 1. Y dash equal current Y position plus M. Then you can plot next point. You can plot the next point and you can repeat it again until x equal x2. You repeat this particular thing and calculate each and every point pair, right? Here you can write x dash y dash. This will happen until x equal, the x coordinate equal x2. You do the calculation. That way you can plot the points. Now here you have to understand this is sometimes most of the time that this value is a fractional value. This value is a fractional value. This value is a fractional value. And you have to do the rounding of that value and find the nearest integer. That is why we are using flow value. We have to find the integer pair of coordinates to point the pixel. Now, when always you go to the next point, you use the previous y coordinate, actual coordinate, right? Right, actual coordinate. Actual coordinate and do that, right? Right. So this is how we do the calculation. Now there is a kind of a changes to be done. Later I will show you what are those changes. Now let's assume I'm copying these things all together. And go to the next one. It's copying. Copy. Right. Let's move anyhow to the next one. I'm drawing the pixel plane here now. Now assume that the values are available here with 0, 1, 1, 2, 3, 4, 5, 6, 7, 8. Other way also we have maybe 1, here 0, 2, 3, 4, 5, 6, 7. Now assume that draw a line find the pixel, right? Find the pixels in between on the line. Find the pixels on the line defined in between 2, pixels 1, 1 and 6, 5. 6, 5. Okay, so 6, 4. This way 1, 1 and 6, 4. Now we know that there are two endpoints, right? Two endpoints we know. One is 1, 1 here. The next one is endpoint we know 6, 4. 6, 4 is here. Now we have to find what are the other points. Next, we'll go to that Dda algorithm. What it says, take two endpoints and calculate the slope. We do the calculation of the slope. We do the calculation of the slope. So m equal slope. First step, calculation of the slope. What is the y? Here 4 minus, here y is 1. 4 minus 1 divided by x is 6. 6 minus 1 again. Equal 3 divided by 5. That is 0.6. 0.6. .6. Now next step, it says plot the x1, y1. Yes, we have already plotted that point, no problem, already now. Repeat incremental on x direction by 1, then x will become x plus 1. Now the next point, I'll take that one as x1. x1 equals 1 plus 1 equal to. Then what is y2? y2 equal, it says y1 or y plus m, the current y position plus m. What is the current y position? Y position is 1. Y position is 1 plus m means 0.6 equal, this equal 1.6. That is 1.6. That is 1.6. Now 1.6 we can approximately tell that is 2. 1.6 plus 0.5, 2.1. Then the flow value is 2. Then plot 2, 2. Plot 2, 2. But actual value of the y2 is 1.6. Remember that one. Most of the time people do mistake here. Actual value of the y2 is 1.6. So y1, sorry. Here, x1, y1. Next again, repeat it until here, x2. x2 equal x1 plus 1. You have to increment by 1. x1 is 2 plus 1, that is 3. X is okay. y2 equal y1 plus m equal, y1 means actual value is 1.6, therefore 1.6 plus 0.6, that is 2.2. This one will be taken as again 2. we cannot put it into 3 or something. That we have to take as 2. Right? That we have to take as 2. Then we can plot 3, 2. We can plot 3, 2. Now let me show those things also. We have to plot 2, 2. 2, 2 means here. Then we have 3, 2. 3, 2 means here. Sorry. 3, 2 is here. And next one is we again calculate what is x3. X3 can take as a x2 plus 1. X2 is 3 plus 1, 4. Then you have y3, y2 plus m. y2 is this one or this one? y2 is this one, 2.2. 2.2 plus 0.6. That is 2.8. Approximately that is equal to 3. Approximately that is equal to 3. Right? But actual value is 2.8. Therefore, we can plot 4, 3. We can plot 4, 3. Right? Now we are going to plot 4, 3. 4, 3 here. Four, 3. Now next thing is x4. x3 plus 1. x3 is actually 4 plus 1, it will become 5. Then y4 equal y3 minus plus m. y3 is 2.8 plus 0.6 equal 3.4. This is approximately equal to 3. You cannot put that as when you add 3.4 with 0.5, 3.9. Flow value is 3. That's how I'm getting it, right? We have done it earlier. Last time. Flow value. Then we plot 5, 3. We plot 5, 3. Let's plot 5, 3. 5, 3 is here. Now x5. x5 equal x4 plus 1. Yeah, incrementing on next direction. So x4 is 5 plus 1, it is 6. y5 equal x4 and plus 1 is given as 6. Therefore, y4 plus m, y4 plus m, y4 is actually 3.4 plus 0.6 will become 4. So we plot the last point 6, 4. 6, 4 already plotted. Now we can see the situation. The first condition of the line is the line should go through the starting point and ending point. What are the starting point and ending point? Starting point is here. Ending point is here. We are going through those points. Starting point 1, 1 we have already plotted, and ending point 6, 4. The calculation is done. It should be continuous. Continuous means there are no gaps. Are there any gaps in between these lines? No. The pixels are joined together. The pixels are adjoined together. So the pixels are adjoined together here. They are joined together here. They are adjacent. Therefore, continuity is available. No problem with the continuity. Right? No problem with the continuity. What else? Then, straight and line should be a line. Okay, that will be shown on the screen. This is a line. We know that there are some deviations available, but it's a natural thing in the digital pixel plane. So like that, only we draw the line. So this is how the digital differential analysis algorithm works. This is how the digital differential analysis algorithm works. Okay? Is that clear? Hello? Is that clear?
Yes, sir.
Okay. We'll do another example, right? We'll do another example. I'll take eraser and erase these things. Right. I'll take this one and put it somewhere here. for your reference. Now I will change this one into this way. 2, 1, 2, 1, 2, 1, then 6, 7. Two, 1 to 6, 7. Calculate the pixel points. 6, 7 means somewhere here. I will show you the points, right? I will do the points. 2, 1 means here. Six, 7 means here. You have to find the pixel points in between these two. Just now try and find the points and plot it before I do it. So this will help you to finalize what is the digital differential analysis algorithm as a total. Do the calculations. Anyone completed? Anyone who has completed? At the same time, I want to tell you that still we are in the mid of the content. We have a lot of things to be done because you know that I'm doing only 2 hours from the 4 hours which is allocated. Now, what I have to do is I have to continue, even though your semester is getting over by another 1 or 2 weeks, we have to continue for another 5 weeks or some more than that maybe to complete this particular session, right? While I'm doing it, I will give you the assignments. Now, today we had a discussion in your institution how to do the final examinations. So in such situations, sometimes the mode of examination may go into change, and there may be different other modes of evaluation will be common, maybe like Viva, and maybe doing the assessment in the homework type of assessment, and you have to present them. Those type of stuff will take place in time to come, right? Anyone completed? You can share your points, list of points you can share. The points what you have calculated. I think you have calculated it in a wrong manner. Deepika, your gradient calculation is incorrect because you have taken x-axis and y-axis vice versa. Not 4 by 6, 6 by 4. So, Rikasa has sent the answers list, but you have to understand, I told you, when you are doing the calculation, even though you use the fractional numbers here, right? I think Sabas one, I don't know whether it is correct or not, but the presentation is okay. The Rikasa's one, the fractional values are there. How can you draw a fraction? I don't know. The full values are also there, right? That's good. That's good. Sorry. One of the place that that is missing because in bracket you have 5.5 Rikasa's one. Otherwise, it's okay. Let's see. 3, 3, 2, 4, 5, 5, 6, 7. Others? How about others? Let's do this one. I'll do it on the same list, right? Oh, sorry. I'll do it in the same list. Here, the 2 points are x is 7, y is 7, and here the first y is 1. Here we can 7 minus 1. Then here we have 6, the x2, x1 is 2. Then 6 minus 2 is to be there. Then 6 minus 1, 7 minus 1 is 6. 6 minus 2 is 4. Then 3 by 2. 3 by 2 means 1.5. 3 by 2 means 1.5. Now, x1, the next x value is going to be, starting point is 2. 2 plus 1 is going to be 3. And y1 is going to be 1 plus 1.5. That is 2.5. That is approximately we have to take as 3. Then 3 comma 3 is the first point to be plotted. Right? I'll take this one. 3 comma 3 is to be plotted. Therefore, we can plot 3 comma 3 here. 3 comma 3 is here. Right? Now next one. x2. x2 is x1 plus 1. x1 is 3 now. 3 plus 1 is 4. y2, y1 plus same. y1 is not 1.6. It is 2.5. 2.5 plus 1.5. How much is it? 4. This is 4. No approximation, anything. Plot 4, 4. 4, 4 to be plotted. So again I will plot 4, 4. 4, 4 means somewhere here. 4, 4. Right? This is x2. Next, I will write x3. x2 plus 1. x2 is 4. 4 plus 1, 5. And y3, y2 plus m. y2 means 4. And m is 1.5 here. And here, it is going to be 5.5. It is approximately 6. Approximately 6. Therefore, 5, 6 is the one we are going to plot. 5, 6. Let's see, 5, 6 means somewhere here. 5, 6. Five, 6 is here. Right? Then the last one. x4, x3 plus 1, x3 here, 4 is 5, 5 plus 1, 6. That is the last point. 6, 7, 6, 7. We should get 7 here. y3 plus m, y3 is 5.5. 5.5. And here 1.5. This is going to be 7. 7. Right? So then we plot 6, 7. 6, 7 here. 6, 7 here. 6, 7 here. Okay. Now let's see whether this is correct. Calculation is correct. We have only 4 points. 3 points in between. These are the 3 points. Line should go through. Okay, now we are going for the rules. If it is a line, line should go through the starting point and ending point. Line should go through the starting point and ending point. Here, starting point is here. Ending point is here. Yes, it's going through the starting point and ending point. No problem. The calculation also there. Going through 2.1, 2, 6, 7. Yes, that's correct. The line should be, the next one is, the line should be straight and continuous. The second condition. It should be straight and continuous. Some kind of a straightness is there, continuous. Is it continuous? Is it continuous? Hello, I'm asking a question. Is it continuous? Continuous කියන්නේ ඒක කෙලි මේ නොනවත්වා තියෙනවා. කැඩේ මැදින් කැඩිලා නැහැ. Hello? Is it continuous? Deepika saying yes. What about others? My question is whether this line is continuous, because we have done the calculation, we have identified what are the pixels, which are on the line. Line එක උඩ තියෙන pixels හඳුනගත්තා. Now my question is whether it is continuous. Sabha saying no. Let's see who are the other people. Kishani, Hiruni, hello. Kishani, Hiruni. Shehan Fernando also saying no. Pragati also saying no. Rashida also saying no. Kishani Disilva also saying no. Okay. Tell me why not? Why not? Gihan, you can switch on your microphone and answer. Why it is not continuous? Make a continuous neve kiyanne ayi ogala. Why is it not continuous? Y value is not continuous. Someone is telling Y value is not continuous. It's it only we consider from the Y value. Now X value is continuous. One by one we are going. Y value is not continuous because jumping. Huh? Is that what you are saying? He's telling Y value is not continuous. Now this algorithm should work on the computer, right? So the computer should be able to draw the line. අපි දැන් ලයින් එකක් අඳින්න කිව්වම ලයින් එක මෙහෙම කැඩි කැඩිය දෙන්නේ නැහනේ. Corel Draw or whatever the software. Line should be straight and continuous. How it will be drawn? That's my question. Now we have to calculate the pixels. Now when we are calculating pixels, whether this is continuous. Many people are saying no. If they are saying no, why? Why you are saying no? I make a continuous කියලා නැත්තේ කියලා කියන්නේ y values continuous නෑ කියලා කියලා තියෙනවා ඒක එකක් okay. Can you see there are gaps? Can you see there are gaps here? This pixel is here, the other pixel is here. In between there are many pixels. We don't know which way we have to go. Here these two are continuous, but these two are not. There are some gaps available. Right? There are some gaps available. Here, the gaps are available. Gaps are available. Therefore, this is not continuous. This is not continuous. Therefore, this one cannot be taken as a solution for line drawing. This particular method cannot be taken as it is for the line drawing. Now, earlier one it has worked, but for this one it has not worked. ඉස්සෙල්ල එකට වැඩ කරා නමුත් මේකට වැඩ කරන්නේ නැහැනේ. What's the reason? What is the reason? It worked for the earlier one, but not for this one. What is the reason? Anyone? ඉස්සෙල්ල එකට වැඩ කළා මේකට වැඩ කරන්නේ නැත්තේ ඇයි? Gihan? 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 ඔසේ නෑ වගේ මේකද? කරුණාරත්න? SK කරුණාරත්න?
Yes, sir.
Why are we saying that why this one is not working but earlier one it worked? Why it's not working here? Now one has told that the y values are not continuous. Y values are not continuous. Why y values are not continuous? Why y values are not continuous? Viduranga? Viduranga. Hello, Viduranga.
Yes, sir.
මොකද මේක දැන් අපිට continuous නෑ කියන්නේ y value සයි continuous නොවන්නේ.
Oh.
Now this can happen for another case, no? Then it is not going to work. How we calculate y value? How we calculate y value? We calculate y value for the previous y value, we add m. For the previous y value, we add m. This is the thing we are using, no? We are using the previous y value added with m. Previous y value will be added with m. When this m is greater than 1, this thing can happen. Pixel එකකට වැඩිය පනින්න පුළුවන්. When m is greater than 1, that y value can jump more than 1 pixel. Then the gaps are natural. Gaps are coming. No one can stop. Do you understand? Is that clear and understood? Yes or no? Is that clear and understood? Yes or no?
Yes, sir.
When the slope is greater than 1, then the value is 1 point something. Then always it is jumping not 1 pixel, more than 1 pixel it is jumping. When x goes 1 pixel, y goes more than 1 pixel. Then these gaps are naturally coming. No one can stop. Right? No one can stop. Therefore, what we have to do is, we have to find some different solution. Now we know that this is happening when the m is greater than 1. When m is greater than 1, we have to do something else. If m is less than 1, no problem, earlier manner we can calculate it. Then this one will work, right? This algorithm works when the m is less than 1. When m is greater than 1, this algorithm do not work. Now the problem is n. Am I correct or not? And is that clear or not? එක පැහැදිලිද නැද්ද?
Clear, sir.
It's clear, right? Okay. Then we have to deal with this particular m, something with the m. Let's see how can we overcome this problem some other way here. Right? Some other way. I will remove these things again. Right? I will remove these things again. And now again I will go back here. Right? Now the calculation what I have done, 1.5, m is 1.5. That is the main problem. M is 1.5. That is the main problem. Now, what I am going to do is, rather than taking the m, I am going to take 1 over m. That means 1 over m I am going to take. Now, how can I calculate that one? Now, as I calculated the equation earlier, y dash equal y plus m. At the same time, I can calculate by changing y direction, x also can be calculated. Changing y direction, I can calculate x also. Let's see how can we increment on x direction. Now here x1 is line. We can plot this one also. And then what we can do is, by incrementing on y direction, y1 plus 1. We are incrementing on y direction. So y goes here, y goes y1 plus 1. Therefore, we say y1 plus 1 equal m x dash. Now we don't know what is x. mx dash, right? You don't have to have this one. mx dash plus c. Now this is the equation which will become as second equation. Right? Now again we do the same thing. The first equation will be, now first equation is here, second equation is here. Let me take this as this one here. This is second equation. We again take 2 minus 1. 2 minus 1 gives you y1 to y1 cancel out. y1 to y1 cancel out. Right? And c to c cancel out. Then here 1 will be remains. 1 equal m x dash mx dash minus mx1. C to C cancel out, right? We can cancel out some of the parts. For example, C to C cancel out. y1 to y1 cancel out. 1 will be there. X dash minus mx dash minus mx1. So that is the thing available. Equal, we can take m out, x dash minus x1. Right? Then we can take this m other side. We can take that m other side, 1 over m equal x dash minus x1. Then ultimately we can write x dash equal x1 plus 1 over m. That means the previous x value will be added with 1 over m. Then we can calculate what is the y value. Y value, new y value is going to be y, capital Y. X value is going to be x dash. Okay, otherwise we can take this y1 and x1 separately. Now the previous x value will be added with 1 over m. Now this is what we have to do if we are going to increment on y direction. That is a good point. That is a good point. Now let's see how to do this thing. We increment on x direction. We increment on not x direction, y direction. Right? By incrementing on y direction, calculate x. Let's see how to do that. By incrementing, so we consider what is 1 over m. 1 over m is going to be 2 by 3. Because this is 3 by 2, this is 2 by 3. 2 by 3 means equal to 0.6667 or 667. 0.667. Then what we do is we add 1 over m, right? X plus 1 over m, y will be added with 1. Y will be added with 1 and x will be added with 0.667, right? 0.667 will be added to that one. 0.667, right? 0.667 will be added there. So now it will become 2.667, approximately equal to 3. Now it is 3. And y1 will be added with 1, then it will become 3. Because we increment on y direction. So first thing is this one. First we have to do this one. And next the other one. Then what we have to do is we have to plot 3, 3. Okay, we are plotting 3, 3. No problem. Sorry, 2 here, 2. This one is 2. 2, 3. 3, 2. 3, 2. Here 3, 2. We have to plot 3, 2. 3, 2 means here. Right. Next again we have to calculate first y. We are incrementing on y direction. By incrementing on y direction, we calculate y plus 1 over m. 1 over m. Here 1. Then this is going to be 3. Here it is 1. This is going to be 4. No, so y is 2, y2. This is 2. 2 plus 1, this is 3. And x2 is going to be 2.67. 2.667. Don't misunderstand. You are not you don't have to take this value. You have to take the real value. Plus 0.667. Then it will become 3 point something. 3.34. 3.234. 234. 3.234. Right? 3.33. Right? That is 3.33. That is a 3.33 here. Right? 3.33 is available, and that will be taken as 3. Right? That will be taken as 3. That will be taken as 3. And now we have to plot 3, 3. 3, 3. Now the plotting is to be done 3, 3. Now again, next value. Here we have to take 1. Y2 is equal 3 plus 1. Then it will become 4. Y is 4. X3 is 1 over m. X2 is 3.33. 3.33 plus 0.67. 667. Then it will become 4. 4. Then we can plot 4, 4. Right? This is 4, 4. 4, 4. We can plot 4, 4 here. Sorry. 4, 4 is, sorry, earlier one also I have made a mistake. 3, 3 is somewhere here. Four, 4 is here. 4, 4 is here. Now, next one. Y4 equals Y3 plus 1. Here it is 4. Plus 1 is 5. Here it is 5. Right? Here it is 5. And this X4 is going to be 0.1 over m. 1 over m. And this one is going to be not 4, that 4 again, 0.667. Then this one is going to be 4.667. Then you can plot, it's approximately that is going to be 5. Then you can plot 5, 5. Here 5, 5. Right? 5, 5. And then again, we have to calculate the same thing. Five, 5, we can plot it. 5, 5 is here. Right? 5, 5. And now we have to calculate Y5 and X5. Y5 is Y4 plus, here the 5 plus 1 is 6 going to be there. 6, right? And here X is going to be X5, X4 plus 1 over M. X4 is 4.667. 667 plus 0.667, that is going to be 5.333. 5.333, right? 5.333. Then it is going to be 5. Then here this one is 6 comma 5. We have to plot 6 comma 5 to be plotted. 6 comma 5 to be plotted. Sorry, 5 comma 6 to be plotted. Sorry, 5 comma 6 to be plotted. 5 comma 6 to be plotted, that is here. We have to plot 5 comma 6, that is here. Because x is 5, y is 6. Right. The next one is definitely going to be this one going to 6, this one going to 7. So therefore 6 comma 7, you can calculate that one. Then this one is here. Now you can see when we change it, when the slope is greater than 1, when the slope is greater than 1, we take the reciprocal of the slope. Reciprocal of the slope means 1 over the slope, and then that one will be added to the x each and every time. Y will be increment 1 by 1. We increase y by 1 by 1. X will be incremented by using reciprocal of the slope. Then we get the points. Now let's see again. Is it going through the starting point and ending point? Yes, it is going through the starting point and ending point. So definitely we can see that. Starting point and ending point, it's there. We can calculate last value is the ending point. Is it straight and continuous? Yes, it seems like straight and the continuity is there. Continuity is there. Here, adjacent pixels are available. No gaps. Can you see any gaps? No gaps are available. Therefore, this is continuous and it's straight, and this can be taken as a straight line. Therefore, we have to understand there is a kind of a change to this particular algorithm. This is not the this is not the digital differential analyzer algorithm, right? So therefore, the additions to be done, we normally say DDA algorithm. DDA, digital differential analyzer, right? DDA. Now, what we can see here is that now when we are working with DDA, if the slope or the gradient is greater than 1, if gradient is less than 1, we can do this way. Right? If the gradient is less than 1, we can do this way. Right? Otherwise, what we have to do is, we have to increment on y direction and calculate the x value. Now here we increment on x direction and calculate y value. So we have to do the other way around when we do in the situation of gradient greater than 1. Right? Here we have to say put another condition. We have to put another condition. we have to put another condition. That condition is here, if m is less than or equal 1. If m is less than or equal 1, we can do this thing. Else, what we have to do? Else we have to go for this one. We have to repeat again, same thing we have to do, but different ways we have to approach. Let me take this one up. What we have to do is, here the repeat again, 5, 5.1, 5.2, 5.3. Increment alone y direction. We are not going to increment on x direction. Increment alone y direction. All the y values will be increment 1 pixel by 1 pixel this way. And calculate x dash or x by using x dash equal x plus 1 over m. 1 over m. Plot next point x dash y dash. And until you have to do this thing, y equals y2. Here earlier one is we are going until x2. Here it goes by until y2 and we plot it. Tamatma sarlai. Digital differential analysis algorithm is this one. It covers whether it is slope less than 1 or greater than 1. How it works? If the slope is less than 1 or equal 1, we increment the x coordinates by 1 and calculate what is y. We calculate it by using y dash equal y plus slope 1 by 1 and round it and plot the point. If the slope is greater than 1, we take the other way. 1 over slope will be taken, and then we increment alone y direction 1 by 1 pixel and calculate x value. X value will be calculated in a manner that x value equals next x value equals current x value plus 1 over slope, and round it and do the x value and plot the x and y values. This is the way we are doing. Now someone can ask, m can be less than 1 by getting the negative values. M can be negative values also, no? Negative slopes are there. Where slope එක negative වෙන්න පුළුවන්. We are taking, you have to remember, we are taking the absolute values. Absolute values. Not the sign. එම්බල ප්‍රමාණය කියන එක ගන්න. එම්බල value එක. negative or positive value එක එකට වඩා අඩු හෝ සමාන නම් මේ විදිහට කරන්න. එකට වැඩි නම් අනිත් විදිහට. Is that clear and understood? Yes or no? Yes or no? Is that clear and understood?
Yes, sir.
Right. Now, I will stop here. This is what we called as digital differential analysis algorithm. This is what we called as digital differential analysis algorithm. May I clean the whiteboard now? Okay. I'll go back to my slides now. Now here we are checking these conditions, and we have seen how the digital differential, now when m is less than or equal 1, the slope is this way. We can draw it, and we don't try to understand it by using this particular slide set, because sometimes it may be complex even though the necessary things are there. Go through my notes, what I have drawn on the thing. And if you have taken notes, that is the best thing you can do. Now here you can see the digital differential analysis algorithm represented in step-by-step manner what we have done earlier, right? And there are some exercises also available. I have shared one PDF with you. That is a very descriptive note. That is a very descriptive note that is available on your Moodle, the vector drawing. And this is vector drawing handout which I have prepared for Bachelors of IT program earlier, very long ago. So that I can share with you. In the line drawing, how it happens, you can see the description you can go through. And it will say what we have discussed here in a very simple manner. And the Dda algorithm is there. And here you can see the line should be visually line should be appear as straight and as possible. Line should start and end accurately, so that the example, if the several contiguous line segments are drawn, there is no gap between them. There should be no gaps. Each line should appear to have even visually thickness the same way. And the conversions process must be faster. That means when you transform the line. Now the case 1 and case 2, both those are considered, and you can go through these cases, what I have explained. And you can see how we have done the calculations here. And then the Dda algorithm is represented in that manner, and we have given you the steps as well. Here you can see the Dda algorithm, and try to do these activities when you come next time, right? Please do these activities and come next time. This is one of the algorithm we use for line drawing in computer graphics. Nowadays it is not used much. The reason is actually you can see that in this Dda algorithm, the slope is to be calculated. Slope is taking fractional value. Bhaga sankhya gannawa me slope එක කියන එක. Later we can see why the fractional values or the partial values are not much efficient in calculations. So we will discuss about it later. Therefore, this Dda algorithm says to be a little bit inefficient. That's why we have to go for a very efficient algorithm called Bressenham line drawing algorithm. Next day, we are going to discuss about Bressenham line drawing algorithm. Before that, you should know how to calculate any points, set of points within a line by using digital differential analysis algorithm. So therefore, please do these exercises and come next time.